Hey guys, you're on GCSE and IGCSE explanations for mensurations. So what mensurations is? So mensuration basically is 3D solids, containers, and working with different, different measurements associated with those three-dimensional objects. Containers, boxes, I don't know, specific geometric shapes like compound shapes that's made of different standard shapes, like made of cuboids, and on top of that the cube, for example. So that's mensuration, and we are here to learn how to calculate the surface area of 3D solids. So that's why we need to understand what surface area of three-dimensional figure of three-dimensional object represents. So in this case, we can categorize different containers and different generally 3D solids onto those which have plane faces or flat faces. Okay, so like cuboids, for example, let's have a look at the front one. It's definitely plane, and each face is actually plane and or flat. And with a curved surface like cylinder, because it has curvilinear or curved surface as the lateral one, and top actually and bottom part represents circles, which are actually also curvilinear. It's flat, however the edges, it doesn't have any edges because of the curvilinear surface, curvilinear circumference around. Okay, so that's why today we're gonna go through 3D solids which has flat or plane faces. There are cubes, cuboids, different prisms, upright prisms, and pyramids. Okay, let's get started. And first of all, I want to give you a definition of what surface area of three-dimensional figure with the plane faces. It's just basically the sum of the areas of the faces it has. Okay, so for example, let's consider a cuboid. Cuboid is a stretched cube. So if you count how many faces it has 1, 2, 3, 4. That's the round, and the top and the bottom. So 2 more, that's why 4 plus 2, 6. So 6 faces. For the cube, the same. Okay. However, there might be questions when you have a container represented by a cuboid which doesn't have the top one. So the top, the lid is eliminated, so it's taken away. So in this case, you will have 5 faces. So be careful about that. So make sure you watch and have a proper look at the conditions of the problems. So be careful with that. Okay, so that's why before we do that, we just write that the total area is simply, I just adjust, sorry. So the total area represents the sum of all the faces. So in this case, we just need to calculate area of all faces around. Because it has, for example, this cuboid has 6 faces, we can consider first only unique faces, because each face, if you consider that one, will have the pair on the other side. Basically on the face, that's going to be a face opposite to your original one. So for example, if you take that front face and I mark as face number 1, that looks at here right now, okay, it has the face from the other side, from the back side, identical. So the size is 12 by 10, okay, 12 by 10. So that's why there are the back side is also 12 by 10. So that's the same rectangle. Okay, make sure you understand that, because cuboid is simply stretched cube and all faces of cube are squares. Now they become rectangles. So each angle here is right angle. So you consider them as rectangles. I hope you understand how to work out the area of rectangle. It's A times B, simply if you have rectangle with sizes A and B. So I hope it's pretty easy and pretty obvious for you. So that basics you need to know. Okay, so that's why for each face, there will be a couple or the pair with the identical area. We can add all those three identical faces. 1, 2, I would say the top one is 3. Okay. Yeah, face number 3. We can add the areas of them and multiply by 2 because we need to double the area. Okay, so let's calculate quick. Area of the face 1 is rectangle 12 by 10, height is 10. And this typically length, that's typically width, and this is the height. So we just simply multiplying 12 by 10, and that's how we get 120 centimeters squared. So pay attention to the units. Everywhere centimeters. In this case, there is no problem with that. So area 2 is the lateral face. It's right there. So I shade it. It's 10 by 8. So that's why it's 80 centimeters squared. And the last one, area 3, the top one, I'm not going to shade, but you understand that's the top face. The size is 12 by 8. So that's why it's 12 by 8, which is 96 centimeters squared. All right, so that's right time to make a subtotal to get this expression in the bracket. So we'll make a subtotal which will represent the sum of all three unique faces, A1. So this is A1 plus A2 and A3 in total. We'll just simply sum up the interim results. Let's do that. So 120 and 80 will get 200 and 296 in total centimeters squared. And now what we're going to do in order to find the total area, so that's the total one, total. So area total is going to be just twice more, so we 2 multiplying by 296. And if we do that, so 296 we multiply by 2, we'll get 592 centimeters squared. All right, so that's how it works. It works pretty simple. Okay, what if the top one is opened? If it's open container, so that's, in this case, we need to eliminate, let's say, face number 3, just only one time. So it might be done in the way. So if opened 3D solid, we need to understand which face actually we don't need to include. Let's assume that's the top one. So let's assume that we need to take away, for example, take away that top face number 3. So we need from the total, if we calculate in this way, we just need to take away face number 3, and simply it means that from the total area of the closed, of their full 6 faces cuboid, we need to take away the face number 3, the area of the face number 3. So that means from that amount, we just simply eliminate, which is area number 3, it's right there, 96 centimeters. So that's why in case of opened, so opened cuboid with eliminated face number 3, which is eliminate A3, area 3, that means we'll take away that as subtracting 96 from that. And if we do that, we'll get 496 centimeters squared left. In case of open, that's the total surface area. So make sure you understand that. What changes might be done if you have a cube instead of a cuboid? So cube is pretty like simplified version of what we're doing here. And let's pretend in case of cube, you just simply want to say that all faces are identical. So in case of cube, all faces will be identical. So that's why you can consider only one face with the area, let's say size is A by A, or the cube with the side A. The area is simply A squared, but we need to multiply by 6 because the cube has all 6 faces as well as cuboid. But they're all identical, so that's why it's enough to calculate just the area of one face. Let's pretend that A is 2 centimeters. So that's the total surface area. In this case, we'll just simply get the following. So 6 times A squared is 2 squared is 4. 4 times 6 is 24 centimeters squared. Okay, so if the cuboid, if a cube has no lid, let's say it doesn't have, it's open cube, in case of open cube, you can do the same and take away the face that you don't need. For example, simply, it looks like you just multiplying just 5 times by A squared. Or you take away, you multiply 6A squared, then take away 1A squared, which will result in the same area. So that's opened cube. I hope it was pretty easy for you guys, but this is necessary basics before we move to the next level. And one more time, I want to say that pay attention to units. Pay attention to units. If you have different units for dimensions like centimeters and meters, so please convert into one format of units. For example, convert meter into centimeters. So make sure you remember that 1 meter is 100 centimeters. Or you can do it later on. So for example, if you're given all sizes in centimeters, let's say you have all sizes in centimeters here, everywhere. So you're given in centimeters, but you need to give your answer for the area in meters squared. So what to do next? You can the first way to convert each centimeters units into meters. So actually the way back, if you're given centimeters, so you need to convert into meters because your final answer should contain meters squared. Okay, so, and that's why if you have meters now as dimensions, so you can cope with meters and finally you'll get meters squared. However, the easiest way to still use in centimeters, and let's say you've got the answer in centimeters squared. How to convert into meters squared? You just simply need to apply the factor 1 over 100 because it stays for each meter. So if you want to convert each centimeter into meter, you'll take 1 over 100 from your result into centimeters, right? But because it's squared, you make sure you understand that centimeter squared, that units for area, and you want to get meter squared, you need to square this up. Okay, so don't forget about this. So that's why the factor of conversion is going to be 1 over 100 squared. Or if you use scientific form or standard form, so using standard form, you can just apply the factor 10 negative 4 in this case. Okay, so that how it works. I'm going to show you any example. I hope you understand how to convert. It's pretty basics. So And that was necessary before we get to the next level. Because in the next video, we will discuss how to calculate the surface area for prisms, for pyramids, still solids, 3D solids with flat planes. However, technique will involve Pythagoras because it's necessary for triangles. There might be unknown sides. We'll have a look soon. I hope you like that. That was Daniel Dallas with explanation for mensurations. And if you're new here, please subscribe, like this video, share with anyone who's interested in math. Peace out.